Imagine standing on a dusty, rust-colored plain, beneath a pinkish-orange sky, where temperatures plummet to extremes and a faint, thin atmosphere barely offers you the air to breathe. Could this desolate and alien environment ever sustain life as we know it? For decades, scientists, philosophers, and dreamers have pondered this question: is there life on Mars, or could it be humanity's next home? Mars has captured human imagination for centuries, earning nicknames like the Red Planet, and becoming the focal point of countless studies, myths, and even science fiction. But today, this fascination is more than a cultural phenomenon, it's a scientific and technological pursuit. From the first telescopic observations to advanced robotic missions, Mars has been studied like no other planet in our solar system. Why does Mars hold such a powerful allure? Its resemblance to Earth, potential for past or present life, and possibility as a future home for humanity make it one of the most significant scientific endeavors of our time. In this video, we'll dive deep into the mysteries of Mars. We'll explore its history, its potential to support life, and how humans plan to conquer this alien world. Let's begin by understanding Mars itself. 1. The basics of Mars, a neighbor unlike any other. Mars is the fourth planet from the Sun, sitting about 142 million miles, 228 million kilometers, away from our star. It's roughly half the size of Earth, with a diameter of 6,779 kilometers, yet its land surface area is almost equal to Earth's, as it lacks oceans. Its reddish hue, caused by iron oxide, or rust, on its surface, makes it stand out among the celestial bodies visible from Earth. The planet has a thin atmosphere composed mostly of carbon dioxide, with traces of nitrogen and argon. This atmosphere is 100 times thinner than Earth's, offering little protection from harmful solar radiation. Mars also experiences extreme temperature fluctuations, from a freezing -195 degrees Fahrenheit -125 degrees Celsius at the poles to a balmy 70 degrees Fahrenheit 20 degrees Celsius near the equator during daytime. However, these temperatures plummet as soon as night falls. Mars has two small moons, Phobos and Deimos, which are believed to be captured asteroids from the asteroid belt. These irregularly shaped satellites add another layer of intrigue to this mysterious world. 2. Water on Mars, a key to life. One of the most compelling reasons scientists are obsessed with Mars is the presence of water, or evidence of it. While liquid water cannot exist on Mars' surface today due to its low atmospheric pressure, numerous studies have revealed that the planet once had a warmer, wetter climate billions of years ago. Vast networks of ancient riverbeds, deltas, and lake basins indicate that water flowed freely across the Martian surface. In 2018, the European Space Agency's Mars Express orbiter made a groundbreaking discovery: liquid water beneath the planet's south polar ice cap. Although this subsurface lake is incredibly salty, it offers a tantalizing glimpse into the possibility of microbial life. Further evidence of water comes from hydrated minerals and recurring slope lineae, RSL, dark streaks that appear seasonally on Martian hillsides. Scientists theorize these could be caused by briny water flowing just beneath the surface. 3. The search for life, past and present. Mars is a prime candidate in the search for extraterrestrial life, primarily due to its similarities to early Earth. The idea that Mars may have once harbored life gained traction in 1996 when scientists discovered the Allen Hills 84001 meteorite, which contained microscopic structures resembling fossilized bacteria. While this finding remains controversial, it sparked a wave of interest in studying Martian geology and climate. NASA's Curiosity rover, which landed on Mars in 2012, discovered complex organic molecules in the soil, an essential building block for life. In 2021, the Perseverance rover made headlines when it began collecting rock samples from an ancient lakebed in Jezero crater, an area believed to have been a thriving environment billions of years ago. These samples could provide the clearest evidence yet of past life on Mars. However, the search isn't limited to the past. Scientists are also exploring the potential for present-day microbial life, possibly hidden underground or within salty water reservoirs. These microbes, if they exist, could survive in extreme conditions, much like extremophiles on Earth that thrive in boiling hot springs or beneath glaciers. 4. Terraforming Mars, science or science fiction. As Earth faces mounting challenges like overpopulation and climate change, Mars is often considered humanity's plan B. But transforming Mars into a habitable planet, known as terraforming, is no small feat. Terraforming would involve altering the planet's atmosphere, temperature, and surface to make it more Earth-like. Proposed methods include releasing greenhouse gases to warm the planet, using giant mirrors to reflect sunlight onto the surface, or even redirecting asteroids to collide with Mars, releasing heat and gases in the process. While these ideas sound like science fiction, organizations like SpaceX, led by Elon Musk, are actively working toward making Mars colonization a reality. Musk's vision involves building self-sustaining cities on Mars within the next few decades. Yet, many scientists caution that terraforming Mars may be impractical with current technology. Instead, they suggest focusing on building controlled habitats where humans could survive within the planet's existing conditions. 5. Challenges of living on Mars, a hostile environment. While the idea of living on Mars is exhilarating, the reality presents numerous challenges that must be overcome for long-term human survival. First and foremost is the planet's harsh environment. The thin atmosphere, composed mostly of carbon dioxide, makes it impossible to breathe without a spacesuit. Additionally, the lack of a magnetic field exposes the surface to harmful cosmic radiation, which could significantly increase the risk of cancer and other health issues for settlers. Temperature extremes are another hurdle. The average temperature on Mars is around -80 degrees Fahrenheit, -60 degrees Celsius, but it can vary drastically depending on the location and time of day. These fluctuations would require habitats capable of maintaining stable internal conditions. Furthermore, the low atmospheric pressure would cause bodily fluids to vaporize without a pressurized suit or shelter, making unprotected exposure to the surface fatal within minutes. Then there's the issue of resources. While Mars has water in the form of ice and possibly briny subsurface lakes, extracting and purifying it would be a complex process. Food production would also pose significant challenges due to the lack of fertile soil, sunlight filtering through a thin atmosphere, and the need for controlled environments. Scientists are exploring hydroponics and other advanced agricultural methods to address this issue, but such systems would require a substantial energy supply and maintenance. 6. Technological innovations for Mars exploration. Despite these challenges, advancements in technology are bringing us closer to making life on Mars a reality. One of the most significant breakthroughs is the development of reusable spacecraft, such as SpaceX's Starship, which aims to carry humans and cargo to Mars efficiently and affordably. Life support systems are another critical area of innovation. NASA and other space agencies are working on systems that can recycle water and oxygen, minimizing reliance on resupply missions from Earth. For instance, the Mars Oxygen In Situ Resource Utilization Experiment, MOXIE, aboard the Perseverance rover has successfully demonstrated the ability to produce oxygen from Mars' carbon dioxide-rich atmosphere, a technology that could be scaled up for human use. 3D printing is also poised to play a vital role in Martian colonization. By using local materials like regolith, Martian soil, 3D printers could construct habitats, tools, and even replacement parts, reducing the need to transport these items from Earth. Similarly, robotics and AI will be essential for conducting preliminary exploration, building infrastructure, and performing maintenance in the hazardous Martian environment. 7. The psychological and social impact of Mars colonization. Beyond the technical and physical challenges, living on Mars would test the psychological resilience of its settlers. The isolation, confined living spaces, and lack of natural environments could lead to mental health issues such as depression, anxiety, and cabin fever. Communication delays of up to 24 minutes between Earth and Mars would exacerbate feelings of isolation, making immediate support or guidance from Earth impossible. Creating a sense of community and purpose would be vital for long-term success. Experts suggest that future Martian colonies must prioritize mental health support, recreational activities, and opportunities for personal growth to ensure the well-being of their inhabitants. Cultural and ethical questions also arise. What kind of society would we build on Mars? Would it follow Earth's existing political systems, or would it offer a chance to create something entirely new? How would laws, governance, and resource allocation be managed in a self-sustaining colony millions of miles from Earth? These are questions humanity must address before embarking on such an ambitious venture. 8. The future of Mars exploration. Mars exploration is entering a new era, driven by international collaboration and private enterprise. NASA's Artemis program, which aims to establish a sustainable human presence on the Moon, is seen as a stepping stone toward Mars. Meanwhile, China, Europe, and other nations are developing their own Mars missions, each contributing valuable insights and technologies. Private companies like SpaceX are pushing the boundaries of what's possible. Elon Musk envisions a fleet of starships carrying humans to Mars as early as the 2030s, with the ultimate goal of creating a self-sustaining civilization. These ambitious plans, however, depend on overcoming significant technological, financial, and logistical hurdles. Public interest and support are also crucial. As governments and organizations invest billions in Mars exploration, they must demonstrate its value to humanity, whether through scientific discoveries, technological advancements, or the potential to safeguard our species from existential threats like asteroid impacts or climate change. 9. The ethical debate: should we colonize Mars? As exciting as the idea of living on Mars may be, it raises profound ethical questions that humanity must consider before taking this giant leap. One of the most pressing concerns is planetary protection. Mars is a pristine world that may harbor microbial life beneath its surface or in subsurface lakes. By sending humans and equipment to Mars, we risk contaminating it with Earth-based organisms, potentially destroying any native life forms before we even discover them. On the flip side, if life does exist on Mars, what are our moral obligations toward it? Should we view Mars as a place to colonize and exploit, or should it be preserved as a natural reserve, free from human interference? Some scientists argue that Mars exploration should focus solely on scientific discovery rather than colonization, as establishing a human presence might irreversibly alter its ecosystem. The ethical considerations extend to humanity as well. Mars colonization is often seen as a solution to the problems we face on Earth, such as overpopulation, climate change, and dwindling resources. However, critics argue that the enormous resources required for such an endeavor could be better spent addressing these issues here at home. Is it right to invest billions in reaching another planet when millions of people on Earth still lack basic necessities like clean water, food, and healthcare? 10. What would life on Mars look like? If humanity does succeed in establishing a colony on Mars, what might life look like for the first settlers? Most likely, the early years would be challenging and highly regimented, with colonists living in enclosed habitats designed to protect them from the harsh Martian environment. These habitats would need to be self-sustaining, equipped with systems for recycling air, water, and waste, and capable of producing food through hydroponics or other methods. Energy would likely come from solar panels, as Mars receives ample sunlight despite its distance from the Sun. Advanced nuclear reactors could also provide a reliable energy source. However, every aspect of daily life, work, leisure, and even social interactions would revolve around survival and resource conservation. Settlers would face unique challenges, from adapting to lower gravity, about 38% of Earth's, to dealing with the psychological effects of isolation. Over time, however, as technology improves and the colony grows, life on Mars could become more comfortable and even resemble a small, self-sufficient town. 11. A giant leap or a cautionary tale. The dream of reaching and colonizing Mars embodies the best of human ambition, our desire to explore, innovate, and ensure our survival as a species. Yet, it also forces us to confront difficult questions about our priorities, responsibilities, and the kind of future we want to create. Mars is more than just a destination, it's a test of our ingenuity, perseverance, and ethics. Will it become humanity's second home, a beacon of hope for future generations? Or will it serve as a cautionary tale about the dangers of hubris and the limits of our reach? Conclusion: Mars and the human spirit. As we stand on the brink of a new chapter in space exploration, the story of Mars is still being written. The search for life, the quest to understand our place in the universe, and the drive to expand beyond Earth's boundaries are all part of a larger narrative about what it means to be human. Mars challenges us to dream bigger, think deeper, and act responsibly. It reminds us of our shared humanity and our collective responsibility to care for both the worlds we explore and the one we call home. So, what do you think? Is Mars humanity's next great frontier, or are we overreaching in our ambition to conquer the cosmos? Let us know your thoughts in the comments below, and don't forget to like, share, and subscribe for more fascinating explorations of the universe.